Okay, everybody. My name is Serena Cerna, and I'm going to be doing Chapter 11, Developing Strategies for Addition and Subtraction. The learner outcomes for this chapter are 11.1, ID the relationship between place value and understanding computational strategies. 11.2, ID 3 types of computational strategies. 11.3, explain multiple invented strategies for addition and subtraction using multi-digit numbers. 11.4, explain the development of standard algorithms for addition and subtraction. ID ways to teach computational estimation to develop flexibility and recognize reasonable answers. And 11.6, describe estimation strategies for addition and subtraction. The big ideas are flexible methods for addition and subtraction. Invented strategies provide this flexibility. In order to use these strategies, students must understand the properties of operations, such as the commutative property. Standard algorithms can cause students to think of numbers as separate digits and lose track of place value. Multi-digit numbers can be built and broken into many different ways to be easier to work with. And computational estimation involves easier to use numbers so that it can be done mentally. 3 types of computational strategies. Direct modeling. This is counting by ones. It's supported by using models, counters, drawings, and other manipulatives. A student might add 123 plus 122 using base 10 models like this. There's also invented strategies. This is any strategy that is not the standard algorithm or using physical materials like the first one we were talking about, the direct modeling. It's supported by recordings and flexible uses, are the basis for estimation and mental methods, can be faster than traditional algorithms and have fewer errors, and they help students develop number sense and place value. An example of this is 53 plus 38, and if a student was to take 2 away from 53 to make 40, 51 plus 40 equals 90, or adding the tens first and then the ones and combining, like 50 plus 30 equals 80, and then 8 plus 3 is 11. 80 plus 11 is 91. Creating a supportive environment for invented strategies. As a teacher, you want to avoid identifying the right answer right away. You want to give all students a chance to answer these questions and give them time to think about them too. You want to encourage students to discuss, interact, and ask questions amongst each other, and allow plenty of time for this so that they can talk to each other and give each other ideas about how they're thinking about the problem. Talk about both wrong and right ideas. Also talk about how one idea can be more useful than one another. Promote using new ideas and being open to trying new strategies. Use familiar story problems and context. This is in order to connect with students and keep their interest, and also connect to prior knowledge. Models supporting invented strategies, addition and subtraction. Break apart strategy, also called the split strategy or decomposition. Students must use their understanding of place value. Example, 133 plus 265. The student would take 100 plus 200 to equal 300. Then they would take their tens, 30 plus 60 equals 90. Then their ones, 3 plus 5 equals 8. And they would add all of those together to get 398. An example of this, there's an example in our book called the jump strategy. For this strategy, it involves using a blank number line Students then record each jump they make, and then they calculate the total number of jumps to get their answer. So in this example from the book, what is 84 minus 68? It says the student started at 84 and jumped back 4 to get 80 to make it easier number to work with. From there, the student jumped to 20, which was 6 tens, so 60. Then they jumped back 4 more to get 16, and they were able to add all of these together. 60 plus 4 plus 4 equals 68. And that is how they were able to get their answer. Bar diagrams and graphs. I found this really cool website on mathisfun.com where students can plug in their own numbers to make a bar graph. This is a great model for comparison problems or part-whole problems. It helps students show and explain their ideas. As you can see in this little example, I was able to plug in the numbers 175 and 133, and then the website made the little bar graphs for me, and I was able to compare 175 to 133. I can also show you that website. It was really cool. Oh, guess I lost it. Okay, for the next part, this is standard algorithms. There's 3 main parts to standard algorithms. Knowing the step-by-step procedure and how to do it, knowing why it works and how and when to apply it, and knowing when to use it. So this is a hundreds chart. This has to do with more the invented strategies. You could combine it with the jump strategy. In my example here, 56 plus 33, you have students start at the 56, then make 3 10 jumps, as you can see in the orange, to get to 86, and then they make 3 more 1 jumps in the pink to get to 89. This was a really, really cool website where you are able to pick, use the hundreds chart in an interactive way. So say you needed to do 45 minus 11. So we could go back 10 to get to 35, and then go back 1 to get to 34 using the jump method. And we have our answer, 34. Back to the presentation. Another great model is 10 frames. This is great for students who are still counting on ones or counting back without seeing the tens. It can help them see place value and gain basic fact knowledge, like facts like 3 plus 4 equals 7. Have students who are already using this strategy explain it to others. This can help the student who's already using it explain their thinking, and it can help the student who is not yet using it see ways to use it. I also found a really cool interactive 10 frames website, and just like this, you are able to start with your frame, your 10 frame. You can start with 5 frame, 10, 20, or 100 frame. For this, I picked 2 20 frames. Then you're also able to pick, if you'd like to use 10s, 5s, or ones. When picking how you want to fill in your 10 frame, you can also draw on here. So say we wanted to do ten. Oop, that came out kind of funky. Let's try that again. So as I was saying, you can also draw on here. So if you want to do, let's say like 16 plus 11, students can come up and fill out the 10 frames and then go ahead and write their answer on the board. I know my students like to come up and do stuff on the smart board, so I thought this was really cool. Subtraction as think addition strategy. It's an awesome strategy for students with disabilities. The idea is to think, how much more do I add to blank to get to blank? And you fill in those blanks. Example, 44 minus 25, you would think of it as, how much more do I add to 25 to get to 44? And then you have students figure that out. And in this instance, the missing number was 19. Another model of subtraction is takeaway subtraction, which can be more difficult to explain to students, and it can be more difficult to do mentally. Subtraction doesn't always have to mean taking away, but many books and teachers emphasize this, so students think of it right away as taking away. Some strategies start by taking away tens, then ones. Other strategies include leaving one number intact by subtracting to the nearest 10, and then subtracting the rest of the tens and ones. These strategies can be done on a blank number line, as you can see in this example from the book. It starts out with the take tens from tens and then subtracting ones. And then with these other models over here, they leave one number intact by not taking anything away from it. And then they use that number to take away from the next. Again, this is used also with the jump strategy, as you can see for this one, starting with 70 minus 30 is what they started with, or 70 minus 40. And so they did that jump to get to 30, and they still needed to jump out their ones, and they went ahead and did that and got minus 6, which was their jump, and they got to 24. Those blank number lines can be really helpful. Standard algorithms for addition, things to remember. Be sure your students know that this is only one possible strategy and that they must decide when it's best to use. Terms regrouping and carrying will have little meaning for young students. Instead, at first, try using words like trading. Make sure they understand 10 ones are traded for 110, 10 tens are traded for 100, and so on. And you're going to want to start with models first. This was kind of confusing for me because I didn't really understand how you would use models with the standard algorithm. But after looking at this example from the book, it made a lot more sense to me. So you're going to want to start with base 10 materials and place value mats. After that, you'll have students record their tens in the one column and ones in the other. So as you see for over here they are doing, let's see, 36 plus 48. So they went ahead and took the 10 models, and they have them right here, and then they have their ones on the 10 frames, and you can see each of them. And then they went ahead and recorded how many 10s. So for 36 we have 30, and for 48 we have 4 10s. So that went ahead underneath the 10s column. For the ones, it was 6 and 8, and that went ahead in the ones column. Then they go ahead and add them, and you can see, so for the ones, they added the ones first. 6 plus 8 got them 14, so they left their 4, their 1 right here, and added their 10 to the 10 side. Then they were able to add their 10s to get 84. Computational estimation. This involves higher end thinking, ideas that students need a chance to think and discuss about. So you need to give your students time to talk about these. Also, you need to explain that some problems need an exact answer while others need an about answer. Use estimation language to help students understand there is no right answer. Language like about, close, more, less than, in between. Use real-life examples and context to help students also understand how there can be more than one right answer. Example, is 5 enough to afford 3 of your favorite candies? The Common Core State Standards says that they need to be able to detect possible errors by strategically using estimation and other mathematical knowledge. 3 types of estimation. There's measurement estimation, where you are estimating the measurement of an object, like the length or weight. Example, what is the approximate length of her hair? There is quantity estimation, problems that involve how many of something, coins or people. Example, how many pennies in that jar? And then computational, any other approximation we may need to make an answer, a problem. Example, will 45 be enough for 3 items? So some of those strategies, the front end method works best when both numbers have the same amount of digits. So like 27 and 45 both have 2 and 2, as you see. Or 345 minus 222, both of them have 3 digits. Take the first digits and adds them to get an estimation, and kind of forgets and leaves behind those ones. So for 27 plus 45, we would just take the 20 and the 40 and estimate about 60. Then there is also the rounding method, where you round one number to the nearest 10, and then the other number stays the same. So an example of this is 54 plus 77. So you round the 77 to 80, and then just add 54. 80 plus 54 is 134, and that would be your estimate. And compatible numbers. This involves adding a few numbers that are easy to work with. So say like 77 plus 13. We know that 7 plus 3 is going to equal a 10. So that's an easier number to work with than 7 or 3. And then go ahead and add your remaining 10s, which was 10 and 70, to get 90. The book also shows a good example of this. In this one, there are 3 numbers with 3 digits each, and they go ahead and add the first numbers, the hundreds, and then they adjust for their tens, and they get about 1350. On the second example, this one just takes the first n numbers, like the first method we talked about. So they just take the first number from each of these to get a estimation. So 300 does not have a thousands place, so they leave that as 0. 4,000, they round to 4,000. And then for 2,725, they round to 2,000. They go ahead and 2,000 plus 4,000 is 6,000. And then they go ahead and adjust for those extra numbers they have. So for my activity, I picked activity 11.12, which is I am but who is. The instructions for this is you make up 30 cards that have different combinations, like 30 plus 10, or harder ones, like 44 plus 57. It starts out with who is 30 plus 10. The person who is holding 40 then reads their card. I am 40, but who is 44 plus 57? The person holding 101 then reads their card, and the game just keeps looping all the way through all the cards. I thought this was great because you could start it easy, very easy at the elementary age, and use like base 10 numbers, like 7 plus 9, really easy, simple numbers at first. And then for middle and high school, you can use much bigger numbers, like in the hundreds and thousands. And of course, for older students, you can go ahead and give them harder ones like multiplication or division facts. Modification gives students with disabilities easier combination cards. Gives students who are gifted cards with harder combinations. An accommodation for this would be to, instead of having each kid get a card and have to read it, they could have a partner or the teacher read the card for them. And this is all for my presentation on Chapter 11. I hope you guys really enjoyed it. Thank you so much for listening.